Hello everyone. Today we'll see one more algorithm of divide and conquer technique, that is merge sort. Merge sort. So in the name itself it is there, as it suggests, it is a sorting algorithm. We'll be having n number of elements and then we have to just sort all the elements in ascending order. Okay. So here divide and conquer technique, that is divide. We are going to divide the array into two parts. This is the first thing we have to follow in merge sort. First we have to divide the array. Until when we have to divide the array? Until I get the single elements, then I have to divide the array. Yes. So once it is done, the division of the array is done, then I have to go for the actual algorithm, that is merge sort. Here two things we have to just remember: merge and sort. While merging only, we have to sort the elements and then we have to merge. Okay, here in this we'll be having two algorithms. First one is for merging and the second one is for sorting. Okay, that is, here the main thing we must know is how we are going to divide the array. So here we'll use the term called as mid element. Okay, with respect to this mid element, we are going to divide the array into two equal parts, that is mid. How we are going to divide identify the mid element, which is the mid element? So for this we'll be having one formula, that is low plus high divided by 2, by taking the average of the first element and the last element, that is array index of first element and the array index of last element. We are going to calculate the mid element. So mid is low plus high divided by 2, and this will be inside a flooring function. What do you mean by flooring function? We'll be getting a decimal number. If we are dividing some number by 2, for example 5 divided by 2, if I do this, then I'll get 2.5. Is it not? In array index we'll be not having any decimal number. To convert this decimal to the whole number, we'll be using this flooring function. We have two things, flooring and ceiling function. For example, 5 divided by 2 is 2.5. Flooring means you have to go back. That means the answer will be considered as 2. That is, answer will be rounded off to 2. If I use the ceiling function over here, if it is 2.5, then you have to go for the next number, next whole number. That is 3. You have to round off that decimal number into 3. But here we are using the flooring function. Okay. Now we'll take an array and then we'll see how we are going to divide the array element. Okay. Let me just take some elements randomly. Yes, these are the elements I have taken. So I'll take some array index. These are the array index. So as I said, what is low? Low is always the first element of the array. This is low. Low is equals to 0. And what is I? I is the last element of the array. This is high. That is, high is equals to 6. Okay. So this is how we will see low and high. Low is first element and high is last element. With respect to this one, I have to calculate mid element, that is mid, m is equals to low plus high by 2. 0 plus 6 divided by 2. That is, I'll get it as 3. Yes, this is not a decimal number, so no need to seal or floor this one. So 3. What is the meaning? At 3, I have to divide the array exactly. So this is the third element. Until 3, this will be the left part of the array, and after 3, whatever the elements you have, all these comes under in the right part of the array. According to the algorithm, always this is a recursive algorithm. First, whatever the operation we perform will be done through the left part of the array. Once the operation to the left part of the array is done, then only it will go to the right part of the array. This is how the recursive algorithm works, because recursion means within the same function it will be just looping many times, that is n number of times, is it not? As I have told, first you have to do the division and then you have to merge and sort. This is first step of division what we have done. What I have told, you have to divide until you get the single digits. Yes, so here these 4 are one part of the array. 20, 50, 90 and 88. These are one part of the array, and 12, 36, 77 are another part of the array. Here we have divided this array into two parts, left array and the right array. One more thing you have to remember, in merge sort always we will divide the array into equal part. Okay, you can just ask me, this is not equal, here it is 4, here it is 3. If we have odd numbers, then always at any one side of the array only one element will be more, that's it. If you take the even number, then exactly it will just divide the array into equal parts. For example, here if I have one more element, then array index is 7, here 4 elements and here 4 elements. Just because we have taken even number over here, so one part of the array will be having only one element more. Now as I have told, this one it will be 0, 1, 2 and 3, and if you divide, this one will become this 4, 5 and then 6. Yes. So here once again I have to calculate the mid element for this one. Low is equals to, mid is equals to low plus high by 2. That is, low is 0, high is 3 here. 0 plus 3 divided by 2, that is 1.5. Again I have to just use the flooring function. Now it will become 1. Exactly here the array has to be divided. That means until 1 I must have this. 20 and 50 are one part of the array. 90 and 88 are another part of the array. Once again I have to divide. I am not going to write part. I have told recursive algorithm first it will just do all the things to the left part of the array and then it will go to right part of the array. Again this is 0, 1, 2 and 3. That is 0 plus 1 divided by 2, 0.5. So it is 0. Here it will divide. So this will be done as 20 and 50. Here 2 plus 3, that is 5 divided by 2. It is 2.5, that is 2. At the place of 2 you have to divide, that is 90 and 88. Now we have divided this left part of the array until I get the single elements. The same thing I have to do for right part of the array also. Here again this is low and this is high. Same thing we have to follow over here. The same procedure. Calculate the mid. Mid is equals to low plus high by 2. That is 4 plus 6, 10 divided by 2. That is 5. Exactly here the array will be divided. This one 12 and 36. This is 77. This one already it is having only one element. No need to further divide this one. This one I have to take. Yes, 4 plus 5, that is 9 divided by 2, that is 4.5, that is 4. Flooring function we are using. So at 4 I have to divide. 12, 36. This is how I'll perform the division. Now I have to go for merging and sorting. While merging you have to sort and then you have to merge all the elements. Okay. So here again I'll just take 20 and then 50. I have to merge these two. Before merging you have to compare. Is 20 less than 50? Yes, condition is true. If condition is true, then no need to swap. If condition is false, then you have to swap these two elements. Condition is true, so I'll just merge these two elements, 20 and 50. Now I'll come over here, 90 and 88. Is 90 less than 88? No, condition is false, swap. 88 comes here, 90 goes here. 88 and then 90. Next, I have told you first it will finish with the left part and then it will go to the right part. So here this complete set is one array, this is one. 20 less than 80, condition is true, no need to swap. I'll just write over here 20 less than 90, condition is true, no need to swap. I'll just keep 20 over here. Next, I have to compare 50 and 88. Is 50 less than 88? Condition is true. Is 50 less than 90? Condition is true. I'll keep 50 here. This is already sorted, so no need to check. So this is how I'll combine. Now all the 4 elements I have combined. I'll go to this part of the array, that is right part of the array. Compare 12 and 36. Is 12 less than 36? Yes. No need to swap. The 77, it is single digit itself. Yes. Then these two. Is 12 less than 77? Yes, condition is true. No need to swap. Is 36 less than 77? Yes, condition is true. No need to swap. I'll just write it. Now, right part and left part, I got these arrays. Now I have to combine these two. Yes, again, is 20 less than 12? No, condition is false. What we have to do? Swap. 12 comes here, 20 goes here. Yes, I have written this 12 here and 20 will be over here. Now I have to just check with this 12. Is 12 less than 36? No. Is 12 less than 77? No. So, no need to swap. I'll keep 12 here. Yes. Next digit. It is 50. Is 50? Now this is not 12. It is 20. 50 less than 20? No. Condition is false. Swap. 50 will go here. 20 will come here. Yes. So compare. 20 is less than 36. Yes. 20 is less than 77. Yes. So I have to write this 20 in this place. Yes. Now I have 50 over here. Now I'll come to this one. 88. Is 88 less than 50? No. Condition is false. What we have to do? Swap. 50 comes here. And then 88 goes here. Again, is 50 less than 36? No. Condition is false. Again swap. 50 goes here. Then 36 comes here. Check. Is 36 less than 77? Yes. Condition is true. So 36 will be here. And then 50 is here now. In the place of 36, 50 is here. Then I'll check with 90. Is 90 less than 88? No. Condition is false. Swap. Now this will become 90. This will become 88. Is 88 less than 50? No. Swap. 88 will go here. 50 will come here. Yes. And then is 50 less than 77? Yes. Condition is true. Yes. This is done and I'll come here. This is 90. Is 90 less than 88? No. Swap. 88 comes here. 90 goes here. Is 88 less than 77? No. Condition is false. 77 comes here. 88 goes here. Yes. Next. Is 90 less than 88? No. So swap. 88 and then 90. So this is how we'll just do. So this is the final sorting. So here 12, 20, 36, 50, 77, 88, 90 is the sorted element. This is how we'll perform the merge sort. First what we have to do? The entire array. We have to use the formula mid is equals to low plus high by 2. Calculate the mid element and then divide the array into 2 equal parts. Okay. Then we have to keep on dividing the elements until we get the single elements. First left side you have to perform and then only we have to go for the right side. Once division is done, I have to sort and merge all the elements. I have to keep on comparing the elements with one another and then I'll be keep on merging all the elements. So this is the array index what we have. So this is how we'll sort the elements using merge sort. And I'll be in the next video, I'll be posting the time complexity of merge sort. Thank you.